Hi, my name is Wouter Emery and I'm the founder of AirShaper. In this video, we're going to discuss how to design electric motorbikes, and specifically, we're going to have a look at why the aerodynamics are so different in terms of cooling, in terms of riding position, and so on. And for that, we interviewed Derek Dorrestein, CTO at Damon Motorcycles, one of our customers at AirShaper. Enjoy this short teaser video and then enjoy the interview.
I'm a longtime motorcyclist, product developer, engineering manager. I co-founded Alta Motors in 2010 with a couple other folks, and so I've been in this electric motorcycle thing now for about 12 years.
This creates a whole lot of freedom. If you switch from an internal combustion engine to an electric drivetrain, the center of mass is different, the layout is different, the behavior is different, the experience is different. How does this all impact your job?
Well, I mean, it ends up being this huge opportunity. We've done something quite special with the way that we put a motorcycle together. The battery is a large feature on our Hypersport platform. We call it the Hyperdrive platform, and we're using the case of the battery as the main stressed component of the chassis. Right, so we've gotten rid of the traditional motorcycle frame, and we've replaced it with our battery case, and that's both given us more room. It's reduced mass. It's allowed us to tune the stiffness of it in new and interesting ways, and it's made a better product. Not only do you get a zero emission vehicle, right, which checks off our one of the biggest boxes that we all have to check. You get a vehicle that actually outperforms the gas bike in most cases, if not all. Higher top speed, faster acceleration. Not to mention that we don't have a bunch of rotating mass in the vehicle that you would find on a big multi-cylinder crankshaft and pistons and all of this whirling complexity that is the internal combustion engine doesn't exist in the electric. We have a really simple motor and gear reduction, and that reduction in rotating mass significantly reduces the sort of apparent mass of the vehicle, right? So because that mass adds forces that resist the vehicle leaning over and changing direction, and without those added forces, the bike feels actually really light. It feels much lighter than a 1,000cc motorcycle. Transitions into corners with less effort, and it's better.
Because it's electric, you have less need for cooling. Is that correct to assume?
Yeah, the electric drivetrain is far more efficient than the internal combustion engine drivetrain, right? So internal combustion engine drivetrains, can be 30% efficient, right? So you've got a tremendous amount of heat that you need to dissipate. The electric drivetrain is in excess of 85% efficient in total efficiency, right? Including all the mechanical losses, the electrical losses, but we have to keep certain components, namely the battery, at a much lower threshold temperature than you would see in any of the internal combustion engine parts. So we have to we have less of a delta T in our cooling system, and because we have less of a delta T, we end up having to have radiators that are very similarly sized to the internal combustion engine radiators to drive the cooling performance that we need.
So how do you predict range where you don't control the way the person sits on a motorbike?
Yeah, it's a little complicated, right? So we end up having error bars around our range estimates because there's a lot of variability both in the shape and size of humans that'll be on the motorcycle, but also in the way that they'll interact with the product, right? So we've for our optimization work, right, where we've lowered our coefficient of drag, and we've looked at all these factors. We've used a standard rider height and mass. It turns out that ends up being somewhat standard across the industry, how people look at this. And then we use a drive cycle developed by the SAE, which is the J2982 drive cycle, which includes an urban leg where you're accelerating, decelerating, where the mass of the vehicle is a big factor and the efficiency of the components are a big factor. And then we use a steady state 70 mile an hour drive and look at the losses there. And that's a big part of our range estimation, and it's an accepted way to characterize that. Of course, if we made the most or the lowest coefficient of drag vehicle possible, it probably wouldn't be very commercial, right? So we have this tension between current design trends in vehicles and the consumer tastes, and a desire to improve our aerodynamic performance.
You have a 200-mile range claim on the website. Aerodynamics, is it 1 mile? Is it 10 mile? What can people just think of?
Aerodynamics is like 50% of that, right? Yeah. If we didn't care at all, we would be really at half of that range.
Exactly,
and so caring about that really matters.
So that was it for our short video on how to design electric motorbikes. I hope you liked it. If you did, please hit the like button, subscribe to our channel, and stay tuned for more. Thanks a lot for watching. See you soon. Bye bye.